Right now, two NVIDIA GPUs on my screen are generating two different AI videos at the same time, and it is costing me nothing. Kaggle gives everyone a free machine with two Tesla T4 GPUs, but almost every notebook uses just one of this GPU and leaves the other one idle. But today we are going to change that. We are going to run a text to video model, but this time both in parallel. And I'm going to show you the one memory trick that is going to make this possible. Now, in order to get started, just come to kaggle.com, go to create a notebook. Now, inside that, just import the notebook. The link of this notebook is in the description box. You can access it from there. Hit upload, import, and you should have this notebook up on your Kaggle workspace. Now, once you have done that, you'll have to do a few settings. Go to settings and go to accelerator and choose GPU T4 into 2. Now, this will give you two T4 GPUs, but whether or not you will be able to use them depends on what you have written inside your cells of the notebook. Now here is the catch that stops most people. You see, we have got two T4 GPUs, each of which is 13 gigs of its own VRAM. Then we have got a shared system RAM which is 31 GBs. And then we are also using this CogVideoX 2B model which alone is 13 GB. Now 13 GB and we are running it twice to generate two videos at the same time. So 13 plus 13, that is 26 GB. Now if we were to run this notebook the regular way, this notebook will crash even before we touch the GPU. So what is the fix? See, 9 gigs of this 13 GB model is nothing but the text encoder. Okay, and this encoder is going to run just for a second. So we load it once, we'll use it, and then we'll get rid of it. We'll delete it. Now you are going to see this all live in one of the cells, which is cell 5. And moreover, at the end, we are going to turn this into a live web app with a public URL. All right, so let's go. Now, before we move forward, one important thing, just go to add-ons, secrets, and just select your HF token. Now how do you get it? I have shown how to get the HF token several times in one of my previous videos. I link that video in the description. You can of course look into the method of getting the HF token from there. Okay, now finally let's start with running this notebook and see what each cell can do. So this is my first cell and let me run this. So it is warming up and it is waiting for Jupyter to kick in. We can see the current status over here. Yeah, so this cell is now running, and if we look over here, the way I have formatted the output over here is we are going to see how many GPUs do we have here, which is Tesla T4, 0th GPU, the first GPU. Now at this moment, we are not really using anything, so we don't really see any consumption being done over here. And this is the monitor that we get from Kaggle. And if we look over here, we see both of them are still at 0%. All right. And we can also confirm that we get around 30 GBs of the RAM. All right, cool. Now, our first cell is done. So let me also tell you what this cell does. So this is a reset cell. It clears leftovers from the memory. Okay. So it will empty both the GPU caches and also print the amount of free RAM and the VRAM. Okay. Now, if during the run of this notebook, if there is a crash, we can come back and start this cell again to reset everything to clear all our partial downloads. All right, so this is the purpose of this. Now this cell is done. Let's come to cell 2 and let's start that. Now this cell is going to install all the dependencies, diffusers, transformers, accelerators, and we'll be using something called as Gradio for the web app. So it is going to install all those things over here. Now this cell 2 is done, and let's come forward and let's hit the cell 3. Now this cell is my settings cell. All my settings, I've done it over here. Now I've got two prompts, one for each of the two GPUs. Okay. Now 49 frames at 8 FPS shall give me somewhere around 6 seconds of video, and 50 steps should give me sufficient quality. If you are low on memory, you can of course reduce this number of steps to further down. Now this cell will also verify that both the GPUs are available before we go any further. So let me run this really quick. Okay, so now it is visible. Now it has verified that both these GPUs are visible to it. Now this cell 4 that I've built is kind of a monitor. A background thread is going to keep printing the GPU memory every 15 seconds. So we'll watch the memory pressure building up live instead of finding out from a crash. Then let me run this. So as of now, it says that it is GPU 0 is 0% used along with GPU 1. Then next one is the cell 5. Now cell 5 is the trick the whole video is about. Okay. Let me run this and we'll see things in action. So now in this cell we are going to load the 9 gigs of the text encoder, but we'll load it just once. Then we are going to encode both the prompts and keep only the outputs, which is essentially just two tiny 2 MBs of the safe tensors. And then we are going to delete the encoder completely and get rid of it. These embeddings are also cached to the disk, so if the notebook crashes, rerunning this cell will be instant. Cool. Now let's come to cell 6 and I'm going to run this. Now look at this place over here. It says text encoder is none. Now what this line is going to do is it is going to tell diffusers that please do not look for the text encoder because we have deleted it. Now the next important thing is this line over here, which is enable the model CPU offload with a GPU ID pin. So this is going to pin each pipeline to its own card, to its own GPU card. So this is going to keep the weights in the RAM and moving them to the GPU only when it is computing. And this is essentially how we are going to stay within the limits of 15 gigs of VRAM. So this slicing and tiling handles the biggest spike, which is during the decoding the final video. Now this is my cell 7. Now this is going to run both the two AI videos generation in parallel. So I'm going to run this and we see that our GPU utilization has started and now both are at 100%. So both my GPUs are now being used live before you. So what is essentially happening over here is we are running two Python threads, one per GPU. Now this can work because PyTorch has got this global interpreter lock which it can establish over the GPU while the GPU code runs, so that both the GPU cards can compute simultaneously. And both these threads are essentially going to share the same copy that is there in the RAM. A separate process is going to duplicate all of it, and that is something we cannot really afford. So let's scroll to the output. So we see that both these GPUs are at 100% and our RAM is also holding up pretty well. Now each of the clips can take somewhere around 20 to 25 minutes. So I will time lapse this part. Alright, so we are back and we see that it took around 1000 seconds. That is somewhere around 15 minutes or 16 minutes maybe. So this both the videos actually took around 15-16 minutes to generate, but they were generated at the same time. And that is the whole point of running things in parallel, right? And most importantly, the peak RAM, well, it stayed under limit. All right. So now this is the peak system RAM observed by the monitor, and these are the stats that we get. All right. So now cell 8, which is the final step, and if let me run this, and now we get the two videos both generated in parallel. So let me play it. Not bad actually. And also we get the two download buttons using which we can download these two videos. So two different videos, two different GPUs, zero cost. So this is not Sora. This is a 2 billion parameter model on a free hardware and a full text to video pipeline that you control. Now we can download this video if we want. Just hit on these two download buttons and you should have this in the Kaggle's output panel, which you can enable by this show sidebar option. And so over here we see this two clips being downloaded over here, and we can further download it to our machines using this. Now cell 9, which is an optional part, but I believe it is also very important. Now this cell over here, it is going to wrap everything into a web application with a public URL. So if you come further down, you would see this link over here and you can hit this and you shall see a Gradio web app coming up live on this. Now this has got a few fields. You can enter the prompt. So I'm going to put in the same prompt here. I'm going to put in this prompt over here. Inside the negative prompt, I'm going to say blur. So that means I do not want any blurry images. Let the frames be 49. Inference step I am good at, and everything else is okay. Resolution, I'm going to stick with this resolution. I've made this fixed, but if you want you can change it, make it variable, but I'm going to stick with this resolution and I'm going to hit generate. Now once I do that, it is going to encode or generate this video over here using one of the GPUs. Now, if I want, I can copy and paste the same URL again, and I will have another web app live. Now I can enter a different prompt over here or enter the same prompt, whatever you want. Let me copy this other prompt and I'm going to enter it here. Negative prompt, I'm going to mark it not blurry, and rest all I'm going to let that be as it is, and I'm going to hit generate. Now you see this is running on the other free GPU, which is the GPU one. All right. You can spin multiple videos on the same URL. Now, if you try to open another video, another URL, and give it some prompt and try to generate another video over there, it is going to queue it. So now as soon as both the GPUs or one of the GPUs get free, it is going to put your third video onto that GPU. All right. So this is a bonus thing that I've added to it. So in short, this app is going to send each request to whichever GPU is free, and all the extra requests they are going to queue up. Now let's wait a little more and we will see this generation coming up. So the video is about to be generated, and if you look over here again, this is still running on GPU 0 and this one is running on GPU 1. So the app sends each request to whichever GPU is free, while if you open another application or another URL, that is going to queue up, and as soon as one of them is done generating the video, it will pick up the next request in the queue. So finally the two videos have come up and I can play it over here. It is kind of the same video but with a different angle and a different dog species, of course. I can download it from here and it took around 17.9 minutes, whereas this one again is kind of similar to what we generated earlier because the prompts are the same, of course. And of course we can download this. This took around 16.9 minutes. This is the seed. So if I use this seed over here, I would be able to generate the same video, and with a little prompt change, I can use the same video, add some changes to it, and refine it even more. All right, so now back on the notebook one more time, and this is my cell 10. Now this cell over here documents how to call the same app as an API endpoint inside your code or inside your application. You can submit a job, poll it, and then download the MP4. Now, there are two caveats to this. The first one is that everything is tied to this Kaggle session. So as soon as the session ends or you close this browser, everything is going to shut down. The live URLs are not going to work anymore. One more thing, another caveat is that each of the generations are tied to your quota. So just be mindful, if you are sharing this URL to someone else, he is going to use up your quota on Kaggle. So primarily there are three things to take away from this video. One, on free cloud GPUs, a shared RAM is usually the limit and not the VRAM. Second, don't keep what you need only once. The text encoder was in fact 70% of the memory and it just ran for 1 second. So we just loaded it, used it, and then finally deleted it. Now the third point is that Python reads are usually enough for multi-GPU in inferences, because PyTorch is going to release the GIL during the GPU work. So now if you want the full notebook, just comment notebook in the comment section and my bot is going to send that notebook to you. You should import it, set your GPUs to T4x2, turn on the internet, set the HF token secret, and you shall be good to go. And if by the slightest of the chance this notebook crashes, just hit the cell 1 again and you should be good to go. So if this video or this notebook saved you a GPU rental, please hit the like button, subscribe to my channel for more such videos, and also comment what should I run next on both the GPUs together. I'm thinking of two different models on each of the GPUs, but that is for the next video. With that said, I'll see you in the next one.